1092, shortest common supersequence. Oh, actually, supersequence, not subsequence. Given two strings, string one and string two, return the shortest string that has both string one and string two as subsequences. Excuse me. If multiple answers exist, you may return any of them. I think I saw a related problem before. But so n is 1,000, so that already means you should be able to do this in about n square. I think it does. I mean, essentially, it does still become, even though it is super sequence. So I think my intuition, my first thought when I think about this problem, is that you still want the short. Sorry, it is you want to solve longest common subsequence, and then the shortest common supersequence is just the characters that are not in that list added to it, if that makes sense. And it's certainly that this test case proves that, though that's not a proof, that's just like, at least it's not a counterexample. But if that's the case, you could solve the longest common subsequence form in n square, and then we just have to reconstruct the array at that time. Cool. And I think that's what I'm gonna start by doing it. I think for this problem, and this is just me trying to learn, to be honest. One thing that I'm trying to be a little bit better about is on doing bottoms-up dynamic programming and not just always default to top-down memorization-based dynamic programming. But yeah, dynamic programming is a lot of people's arch nemesis, and maybe mine too. But yeah, let's say n is equal to 1. What do I want that to be? So the longest, so let's just say is 0, okay? Yeah, I guess 0 is a good development. Times n for in range m. Forgot how to parents. Maybe I want it by 1 actually. Also, this is already needs to be, yeah, okay. And 1 goes probably a pain. I don't think you could get away with 1 go in that sense. Because, I mean, it depends on what you mean by 1 go, but you need to reconstruct. So with dynamic programming, you need to kind of do a path reconstruction, and usually that just another traversal is backwards. So it depends on what you mean by 1 go, but it's still 1 DP. Yeah. Oh. Yeah, it's hard to get right. I mean, I think it takes practice, but not super hard in theory. Typing it in 1 go, yeah. Dynamic programming is, I think this is a little bit beyond the scope of how I could explain it, but it's basically a way of structuring a problem such that you solve the subproblems. You answer a problem by answering problems that are related to that problem. That's kind of the way to do it. The canonical example is I would look up, if you have someone to Google, just Google for dynamic programming Fibonacci. And that's usually the one that everyone gets started on. And then there are a couple of ways to go about that. But yeah, I mean, I also recommend MIT. Thanks, sort of destroy. And I also recommend for dynamic programming the MIT algorithms video course. It's very good by Eric Domain, Professor Domain. He's very good. Yeah. No, I mean, so Philip Destroyer, to kind of answer your question, actually, I got into competitive programming recently. It's an addiction. So I've been just doing a lot of practicing for competitive programming. So that's kind of the story there. Cool. Okay. So anyway, for X. So yeah. So without dynamic programming background, I'm afraid that this is going to look really crazy. Um, but what are the transitions? Um, what the? Oh, because string is a. Oh no. What I want is this. Whoops. All right, and then your best is just always gonna be yeah, maybe +1. Yep, you could do that within the same loop, but I just like doing it in different loops for clarity. And yeah, let's print out the best, and then we should return a placeholder for now. Yeah, you're not wrong in that it's a waste of time, but I do it for fun more than So I mean, anything you do for fun is a waste of time mostly. So right? Did I do? I might have swapped the N's and the M's. I feel like I always do that a lot with these type of things. Um, what is the index that's our range? Not this. Probably this. But I thought I have. Oh, maybe I swapped these. Actually, that sounds right. Actually, yeah. I think that. I mean, some of this is like Python specific because in whatchamacallit, in C, I would never get this wrong just because the orders are always in a good or better maybe way. But yeah, you see that the most common is here, but now we have to construct the array. That's the hard part. Um, okay. For this, you generally have to kind of keep track of the previous one. I'd like to just do, and then here, just to prove, oops. Let's just go at 0. The way I do it is a little weird. I need to fix this time. This time of programming isn't quite. I mean, it's good enough, but it's not quite right. But oh, CTF. Yeah. I mean, it's all good. I don't know if I know what CTF is. Oh, capture the flag. I mean, anytime you do things for fun, it's okay. I'm not a big crazy, thing for it. Else, I need to clean this up a little bit. Okay. One is bigger than y +1. Then we do this thing. Otherwise, then we want to get the max of one of these. Is that right? Then let's just say let's just call this, actually let's just call this 3, this is 2. I'm using mental bit masks. There are other cleaner ways to do this, I think, but well, I mean, I guess the cleaner way is just to use enums. Well, actually, it doesn't even have to be an else. Technically, this could still happen. So let's relax those things. Okay, cool. So let's see, making sure that doesn't crash should be okay. Should still give me the answer. And also now, if we did it right, we don't actually even need this best. We could actually print out just dp of n of m. Oops. Assuming you know how to type correctly, which for me is not a given. Okay, well, mistakes were made. Oh, because we don't. I guess usually people do this backwards. Oh, because, well, it's just because we don't. We do not do the last rows. Okay, fine. But then now we have to add bounds to everything. Oh no, wait. I think the way I constructed, I don't use the 0 one. So actually, sorry, I get a little bit confused about offline ones on DP. So let me think about it. I also usually do it the other way, but I've been kind of trying to be better about this in general. Okay, fine. Let's actually do it this way. And actually, what I want is if so you go to say 0 for now. Well, I guess that's already the case. And then you go if. Now, if I do it this way, then I start from the first one. And dp of x, y is equal to dp x minus 1, y minus 1 plus 1. We'll actually have to check the size. If this is smaller than this, and then now we have to check the other cases, which is if xy is, oops, dp x y minus 1, you don't get a plus 1 because because you're not cool enough. And dynamic programming could look like gibberish, but I assure you there is some madness in the quality. No, the other way around. Okay. Hopefully this should work. I think this should be good. I rewrote it so that this will definitely get populated with the proper cases. But maybe I get infinite loop instead. Why is it taking so long? Okay, cool. So we do get the right answer. And in this case, we only have to look up 1 instead of the entire table. So let's get rid of this. Cool. And now what does that mean, right? So that means in what we call the priv, well, priv n times m is equal to, or not equals to -1. Then let's go backwards to construct a string. We actually don't even need a DP array anymore technically, and you can actually kind of reproduce this without this priv array, but I usually do it with a priv array that kind of allow a more straightforward path construction thing. So yeah, let's do if priv. Oops. I should say x is equal to n, or xy is equal to nm. X and y is equal to 3. Then let's subtract 1 from both of them, and then this may be backwards. I think if I print it now, then it'll be, or if I return it now, it'll be backwards. But let's just say there's a result is equal to some empty string, and then notice that I think in theory you want because you're going backwards, you need to reverse this. But I'll reverse this later. That's not that hard, right? So yeah. So that means the string is the same. So at that point, we just take one of them. It doesn't matter which one. Let's get the character before we decrement. Else if xy is equal to 2, and as 2 is if we take it from the y, because that was a better path. So that's, but again, result to y, and then now else if you go 1, then we take it from the x again. So and again, this should never happen, but maybe it can. Let's just to make it never happenable. Let's make this actually -1, but okay. Actually, let's make this default. Let's say -100, some negative infinity, but then set -0, 0 is 0. Actually, let's make the n is equal to 1,000. So let's make this like a big number. This should never happen, so let's not worry about it yet. And then let's see. In this case, actually, the reverse is the same, so maybe that's not a great example. Name my booleans. These are enums, but you're not wrong. String of index. That may be the. That's oh, because I'm off by 1, because that's the way I did this, I think. Because for xy index, I choose x and y minus 1. So let's actually do that. Oops. You're probably not wrong. Oh, close, but not quite. Let me just print out passing, just in case that was the reason. Oops, I guess I don't need pass, but then it would go in an infinite loop, so that's probably not it. So, because I think I go to the, so this should happen once. So okay, that's actually kind of expected, but you have to do it once because there's, like, if you think about it as a root on a tree, you get to the root, so there's no previous, so then you have to print that one case, right? But which one do you print? Let's forget. Let's just print out the x and the y. I think I actually have to distinguish a little, but I think maybe I have to set my base case a little bit right. But yeah, in this case, obviously you want to go to y. Okay, actually that makes sense, because I never declare, and you could kind of reconstruct your base case so that that's a little bit better. But I would just go if while x is greater than 0, result, because the order I think should not matter in this case. And then now you do the same. And remember that these are y or one based, one indexed. Oops. Oh, well, I mean, it'll be easier for it to not one infinite loop if we decrement it afterwards. So, okay. I mean, I think this is reversed, so let's try another case because I'm really dubious of this. So let's just say this, and then, I don't know, right? If this goes right, then the C should be in the front. I had to add the string quotes, air quotes, no, real quotes, I guess. I click. I thought I can't click correctly. Yeah. So okay. So this is what I expect, kind of. Maybe not. Actually. Because in no universe is this right? But I think we needed to just reverse this, and that should be fine. Because we were putting in a weird, like I was saying, we were going backwards, so you expect the results to be reversed. So yeah. Is there a Pythonic way to reverse a string? Is it just like, does that work? Is that still a string, or is it just a slice? Definitely still learning a little bit about Python and like weird things. Okay, so that's right. Cool. Well, let's kind of do another few cases. That's it. I guess. Oh, it's at least one letter. Okay. I mean, this just ends up being some variation of A, B, 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 B. I don't know. I don't remember how many times I said it. The judging is kind of slow right now today. Maybe. Or is it just me? Okay. In the interest of time, I'm just going to... well, actually, let's just do one where it's fully... let's just fully... whatever. Like, overlapping. Intersecting. If you're so judgmental. Okay. So yeah, so now let's just submit, and then we'll see. Okay, cool. Yeah, it could have been faster, I guess. I think it's always hard to tell sometimes whether you need to go top down or bottom up with respect to unreachable states, at least without kind of doing it. It's possible that this one has a lot of unreachable states due to the early non-intersection, but that's not a big deal. Don't know why it's slower than a lot of people. Maybe I'll talk about later. Yeah. Oh. Wait, string append? Oh, because it creates a new string afterwards. So maybe that's a good point. You're definitely right in that. I mean, for the purpose of competitive programming and stuff like this, I don't really think about. I mean, sometimes I do when I know that the running time will be depending on it. In this case, maybe that's why it's so slow. But you're definitely right, and I think also like I think a common interview tip is that I always bring up strings just to kind of show that I know how strings work and that like I'm inefficient in this interview because for time purposes when I'm in an interview I'm just trying to get it to show that but I also would point out that like well, there's a production code I would do string buffers etc. Right, string buffer, string builder depending on whatever language you are, and that's probably actually why my thing is too slow, but that's fine. I mean, I I added to the end and then I reversed it. So these are just like unnecessary time, but they're also like not the dominating times, which is why I don't care about it. Because this is always going to be n times m, but this is roughly, well, it's strictly less than n times m, even though it's not necessary ideal in the chance. I think this is a little bit harder than a normal interview question for sure. Path construction is not something that I personally would consider in scope for an interview question because that's it's non-trivial for sure, and it's hard to get right. I did get it right in one go though, MBRAX kind of. I mean, well, at least like I did testing along the way, obviously, but I knew my expected behavior each step of the way for the most part, so I'm very happy with that. But yeah, this is a Leetcode contest problem, but that I did in about 25 minutes, but I think I talked through it a little bit. That's my, probably could have done it faster for sure. And maybe confuse these. Maybe I would have used C. but uh, but yeah, definitely I was for competitive programming. This is actually very straightforward for competitive programming. But for interviews, I would not worry about it. I mean, I would worry a little bit about the dynamic programming for certain companies. If you do your research and they're a company that has dynamic programming problem, then you have to know about it because this is relatively straightforward. Like if the question is, what is the length of the shortest common supersequence, then you should be able to answer this very quickly. I got most of that code up pretty quickly without the previous traversal. But and yeah, and thanks to Google on for this problem is dynamic programming and path construction. I mean, I could explain it a little bit in more detail, but those are the kind of things that if you're watching it and if you're not live, if you're watching this a little bit later, that's what I would Google on. But otherwise, a straightforward application of that thing, but not, you know, but otherwise, and the nuances on the path construction, which is a little bit tricky. But yeah, again, for an interview, I would be shocked at that. I mean, sometimes, like, for an interview, you just get problems and you're like, well, I will see you next year, and when I interview again or something like that, because sometimes the luck is not in your favor. Yeah, GG, well played. Better luck next year. But but I mean, because you don't have infinite amount of hours. You should study on things that you're not as strong on, that are more fundamental than studying this. That's what I would say. What is the hint? I'm just curious. If we can find, okay, we knew this already, or I knew this kind of already. But yeah, cool. Yeah, so that was a fun problem, a good practice. Thanks for the problem, MBRAX. Definitely something that, like I said, I've been practicing the bottoms up a little bit. Not as much as I would like, but still a little bit more as usual. It's good.